Okay. We'll give another minute, but then Prachi, I think you can, with our usual intro stuff, you can get started as folks come in. Ooh. Ooh. Okay, should we get started? Ooh, where'd Prachi go? Oh no, hang on. Oh, she's there. Okay.
Can you see the new slides?
Yeah, we can.
Okay. All right. So hello, everyone. Welcome to our series where you get a chance to meet a space professional. And this event is being hosted by Indus Space in collaboration with Astro STEM Labs. We at Indus Space would like to acknowledge the various Indigenous lands we reside on as an organization, including the traditional lands of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. We would also like to thank our sponsors, Ontario Regional Malayali Association and Stonehaven Dentistry, for supporting our endeavor. So a little bit about the host. So Indus Space is a social enterprise with headquarters in Mississauga, Ontario. Indus Space raises awareness specifically about space explorations and its connections to science, technology, engineering, arts, and mathematics for youth, educators, and the general public. We provide products and programs for all grade levels. Astro STEM Labs is an after-school STEM club based in Mississauga, Ontario. Astro STEM Labs' mission is to make learning of STEM subjects fun and exciting for children in grade 1 to 12. They conduct online coding, robotics, engineering, maths, sciences, and chess classes for kids across Canada. Please follow us on our website, Twitter, Facebook, LinkedIn, and Instagram. You can tag us with hashtag CDN Space Talks. This is a reminder that this event is being recorded. So if you do not consent to being recorded, please keep your camera off. If you do leave your camera on, that means you do consent. So for today, if you have any questions, please use slido.com. I will also submit the link in the chat window, but the code is Space Talks, and we will have time towards the end for questions. So some ground rules. So everyone should listen closely and respectfully. Ask questions when you're curious or confused. Keep your questions and comments short, and most importantly, have fun. So next week we have Kelsey, and she's going to be talking about satellite operation. And this week we have Hira Nadeem. So she is currently pursuing a Master's of Engineering Science in the Electrical and Computer Engineering Department at Western University's Institute for Earth and Space Exploration. She's a strong believer in interdisciplinary involvement in the Canadian space community. She hopes to one day work on an exploratory mission to Mars and use her background to help with sustainability on Earth. Today, she will talk to us about cube satellites and how they make space more accessible.
So over to Hira.
All right. Can everyone see my screen?
Yes.
Yep.
Perfect. All right. Hi, everyone. My name is Hira Nadeem, and as Prachi introduced, I am a Master's of Engineering Science at Western University. And today I'll be talking to you about cube satellites and how they make space accessible. So just some background about myself. I did my Bachelor of Electrical Engineering in Hamilton, Ontario at McMaster University. And now I go to Western in London, Ontario. I really hope to work on projects that aid in exploration, Mars, the moon, as well as sustainability on Earth and in space. But I'm excited to see what my thesis will bring me in the next year. During my undergraduate degree at McMaster, I had the opportunity to work at 2 space companies. I worked as an engineering and research assistant at Sinclair Interplanetary in Toronto, which is a satellite parts manufacturing company. They make kind of these little wheels called reaction wheels and star trackers, which help to orient a satellite in space or kind of give an idea of where the satellite is in space. I learned a lot at that job, and then I went on to work at Planet in San Francisco as a manufacturing and test engineering intern last year. And Planet is an Earth observation satellite company with the largest satellite constellation of cube satellites for Earth observation. And their goal is to take a new picture of Earth every day to provide people with better insights of how the world is changing and to help them make better decisions about the Earth. So, you know, if you've ever been on Google Maps, they pretty much take pictures like of the Earth like Google Maps every day. So as well, I've also worked on a couple of Cube satellite missions as a student over the past couple of years through the Canadian Cubesat project with the Canadian Space Agency. So I started with the McMaster Newtos Cube satellite mission, which I'll talk about a bit during my talk. And the goal of that project was to detect radiation in the atmosphere for understanding how it affects astronauts in space. And now I work on the Western Cube satellite team called UCPIC-1, which is the goal is to send up a 360-degree camera, which will take a video once it's deployed from the International Space Station, which will be super cool. And both those satellites are going to launch next year, the end of next year. So a lot of my experience is from the student perspective, but I've seen the big impacts that these small cube satellites have on the industry, and I hope to provide you with that perspective throughout my talk. So you might be wondering, what is a cube satellite? Cube satellites are small satellites that are 10 centimeters long, 10 centimeters wide, and 10 centimeters high in their smallest form. So that 10 by 10 by 10 measurement, like right here, makes up 1 unit. So that's called a 1U CubeSat. And they can be stacked to create larger structures up to 24 units. So those are pretty big cube satellites, but they're still considered small cube satellites. Generally, I've worked on 2 or 3 unit satellites, which are about 20 centimeters long or 30 centimeters long. So like the size of your ruler. And those are pretty small. In comparison, regular satellites that you might hear about that do communications, like providing, satellite, satellite video, internet, different types of things. They are much larger and can be as big as like a rhinoceros, whereas these cube satellites are the size of a duck. So they're quite different in size, and they're still able to hold a lot of different components that help them do a lot of different things in space. So the cube satellite model was developed in 1998, so not that long ago, just a couple of decades. And it was developed in California at the California Polytechnic University and a group at Stanford University. And so following that development, they launched the first cube satellite in 2003. Over time, the cube satellite model has become more standard, and more people in industry at different agencies like CSA, Canadian Space Agency, and NASA, and around the world have started to use it because it's a very successful model. And right now there's approximately 2,000 cube satellites in orbit and many, many more to launch in the coming years. So inside of a cube satellite, it generally consists of kind of a metal frame, a mechanical frame that houses all the components. And I'll kind of explain a little bit more of what that looks like. So in this image, you can see there is this kind of frame here, which is that mechanical structure I mentioned. Inside, there's all these little boards. So if you've ever opened like a computer or any kind of electrical component, you'd see like a green board with a bunch of little components on it. That's pretty much what these are. They just have different components that do things like communication. So talking to the Earth from the ground station up to the satellite. They have like the power system. So powering on the cube satellite so that it actually works, batteries, things like that. The onboard computer. So if you think about your computer that you're using, it's quite big. And now imagine a much smaller thing about this big, which is basically a computer, and it's inside of this satellite. So it's very small, but very, very powerful because of the components that are on it. And then there's some kind of attitude control. So whether it's, rods that induce a magnetic field that aligns with Earth's magnetic field, or it's just kind of, metal rods that do it passively. There's a lot of different ways to make the satellite orient in space so that it's doing what you want. So that's all kind of like in this area. And then that's all packed inside this aluminum frame. And then there's these panels on the side, which are the solar panels. So there's no plugs in space. So if you want to power the satellite, you need to use solar panels. And they're able to produce energy to power the satellite. So as you can see in this picture, it's quite compact. Everything is inside of the cube satellite, and there's just a lot in there, and they do a lot, and it's pretty phenomenal. So these CubeSats generally launch into low Earth orbit. So if you look at the atmosphere, starting at the lowest level, usually around 10 to 12 kilometers, you'd be in an airplane. That's kind of where you would be flying. Above that, that's where kind of the ozone layer is with, weather balloons and fighter jets. And then above that is the mesosphere, which has meteors. And then one more above that is the thermosphere, which is about 80 to 700 kilometers above sea level. And so CubeSats are generally around like 400 to 600 kilometers, depending on their orbit. And this is also kind of where the ISS is, the Hubble Space Telescope, Aurora Borealis. And so it's quite far off of the Earth, and it's, almost into space. There's still a little bit of protection from the atmosphere, but not that much. And so they're still susceptible to radiation. So the atmosphere is there to protect us from radiation from space. We can't be in space because there's no air, but also there's a lot of radiation. So when astronauts are on the International Space Station and when they're outside kind of walking around, they have these big suits to protect them from radiation and also provide them with air. And so satellites are also susceptible to this radiation and can be harmed. And so cube satellites don't have as big of a problem with radiation because they're not up there for that long, because they're so small. The missions are usually also very short. And so it's not as big of a deal, but yeah, they get bombarded with radiation, which can be a problem for them long term. And there's a lot of ways for them to get up there. So they get launched on rockets. So there's a lot of new rocket companies in the past decade that have kind of shown up to take small satellites into space. For example, SpaceX, there's Rocket Lab, Virgin Orbit, and many more. And recently in January, SpaceX launched their largest rideshare mission with 143 CubeSats. And that's a big number of cube satellites going into space on one rocket. So that was pretty exciting for the space small satellite community. And then when they're in space on these rockets, they get deployed, which means that they are released into low Earth orbit, and they can now float around and do the mission. And so they can either be deployed straight from the rocket, either released, or they can be sent to the International Space Station from the rocket, and then from there they're released. So I actually have a quick little video of this from the Canadian Space Agency. So as you can see, this is the deployer, and that's the little CubeSat coming out of it, and it's just floating. And so it'll eventually kind of orient and do the mission. But this is the Exalta 1 cube satellite from the University of Alberta. And so they launched that cube satellite in 2017. So it's pretty interesting to see like another student CubeSat launch into space. But yeah, so that's pretty much how they get deployed. So you might be thinking, wow, that's like really interesting technological thing that is being built. It must take a long time. And it actually doesn't take that long in comparison to other satellite missions. So usually it'll take 2 to 3 years to design and build and test a cube satellite to get prepared for launch. There's a lot of different reviews that happen. I think like any project should just get reviewed a lot. So if you're working on a big project, it's very good to just like review and reflect on them. That's kind of what we do with cube satellites is we, as we're going through the mission, we think, okay, like, is this design work for, you know, the entire mission? Is there anything that we need to change? Are we okay with purchasing these materials? Things like that. So that kind of all happens in this first phase, which is probably, I think, the longest phase. And then after that, we kind of stop designing and we're like, okay, we're going to build it now. We're going to test it and we're going to make sure it's ready for launch. And so that happens in this next phase. And after that, they do this thing called the flight readiness review. And so they talk to, you know, NASA or the Canadian Space Agency or both, as well as the International Space Station and different government bodies to figure out if it's safe to launch and everything is good to go. And so that happens. And then if everything is good and everyone's happy with it, then they'll launch the cube satellite, and that's when the mission starts. And so that's called mission operation. And you'll be hearing from Kelsey next week, who will talk a lot about mission operation of cube satellites with her job. And that for cube satellites, especially in my experience with student teams, they're like 1 year. It's not that long. Whereas you might see like big satellites from different companies that are in space for like 10 to 15 years. So it's a very different timeline for them. But yeah, it's much shorter and a lot easier to manage. Can you imagining like a student myself, you know, I'm in school for 4 years in my undergraduate degree. I could probably see the entire timeline of a mission like this while I'm in school. Whereas a bigger mission, I'd probably, you know, miss out on quite a bit of it. So in general, cube satellites are really good in comparison to general conventional satellites because they're more, they're inexpensive. They can use a lot of available things that you can find on the shelf. Sometimes, honestly, people use things that you can find at a hardware store or at, you know, an electronics store. So it's not like you need to have like really interesting and space qualified and NASA approved, you know, hardware. You can use very simple things and kind of send them into space and they'll do the job because, as I mentioned, they're shorter missions, like a year or 2 or 3. So radiation is the biggest reason why they very carefully select hardware. And you know, if you're only up there for a couple of years, it's not that big of a deal if it gets bombarded with radiation. They're also simpler to build because it's smaller and the complexity is just lower. So as well, shorter development times, as I mentioned, and, you know, big cube satellites take like 7 to 10 years to build their first satellite. After that, it could take maybe 3 years to build the next version of it. But with a cube satellite, it takes like 2 to 3 years, depending. And then the next iteration would be like 1 year. So it's a lot quicker to build these cube satellites. Of course, they don't do the same things as these big satellites, but if you're just doing a couple of things, as I'll go over in a little bit, you don't really need that big of a satellite to do it. Another big reason is up-to-date technology. So if you think about it, iPhones are released every year. You know, I think they're coming out with like the 13, 14, I don't really know which iPhone they're on, but they update that technology very quickly. So if you think about a Cube satellite that launches, let's say this year, and a bigger satellite that also launches this year, because the bigger satellite was designed and then kind of stopped designing earlier, say maybe 2-3 years ago, whereas a Cube satellite probably stopped designing like last year, you're going to get a bigger satellite that uses, you know, an iPhone 6 type technology, whereas the Cube satellite would be using like an iPhone 11 type technology. So you're going to get better hardware, better technology on a Cube satellite because it takes less time, whereas with a big satellite, it's much older. So of course, I'm not saying iPhones are going to space right now, but I will talk about how phones have gone to space shortly. As well, there's other reasons like it's lower risk. So imagine if something goes wrong with a Cube satellite, because it only costs like tens of thousands of dollars or hundreds of thousands of dollars, it's not that big of a deal if they need to remake it. It also takes less time to send up another one. Whereas with a big satellite, it's like a couple $1,000,000, like a few $1,000,000. And that's more of a high risk thing. They want to get it right on the first try. And so you can really experiment with Cube satellites versus bigger satellites. And yes, like I mentioned, there's a lot of launch opportunities, which is great. They can fit a bunch of Cube satellites on a rocket. And this also helps a lot with scientific research. So at a university or college, if they have a smaller budget, they can launch a Cube satellite, but they probably don't have millions of dollars to launch a big satellite. So there's a lot of different types of payloads that are on these satellites. So it's not just about the electrical system and the computer and stuff. It's all driven by kind of what you want to get out of the mission. So there's things like technological demonstrations, which are pretty much like, hey, we want to try a new technology in space, see how it reacts in space. And if we can kind of build upon that and make it on, like make it work on a different mission, like to the moon or a Mars rover or something like that. Like the space environment is a very interesting and different environment than on Earth. So it's really good to get that experience in space. There's also commercial payloads. So companies will use Cube satellites to actually do a lot of stuff. You know, it's not just big satellites that are used for communications and internet and looking at the Earth. Science missions are also very commonly used for Cube satellites because a lot of scientists and researchers can use Cube satellites to send up instruments like telescopes, cameras, things like that to test them in space and also collect data. And then educational projects. So it's really important as students, myself included, to learn about how these missions happen and what we can provide as students, and also to train us if we do want to work in the space industry later on, and we'll have that experience. It helped me a lot being on a student team. So that's kind of the main areas in which Cube satellites are focused. So some examples of payloads would be one being, as an example of a technology demonstration, would be the Phonesat mission from NASA Ames Research Center in California. This was a mission from 2010, and the goal was to see if they could launch the lowest cost satellite ever. So they basically used a bunch of materials that are commercially available and not necessarily used in space missions. And one of them was a phone. So they actually took a phone and put that on the satellite. So you have a cell phone probably, or you know someone who has a cell phone, and you can probably tell that they do a lot. You know, they can access the internet, they can take pictures, they have pretty fast capabilities. And you know, you can drop it and it doesn't break most of the time. So these researchers kind of recognize that, oh, phones are really, you know, compact, very slim, very small, and they can do a lot. So why don't we send it up on a satellite? Obviously, sending a phone into space is tricky because, like I mentioned, there's radiation. And also when you send something in a rocket, it shakes a lot, so it could break. And so they wanted to see if that could work. And they are actually very successful in this mission. They were able to send the cell phone up and get some insights about whether it was working. It was able to communicate that it was able to, function in space, and also took a picture. And this proved that you could send up, smaller compact cameras like this to take pictures of the Earth from space. So yeah, it was very interesting technology demonstration. And to add to that, you've probably heard the computer that was used on Apollo 11 for the moon landing had less computing power than a calculator. So can you imagine how much capability a cell phone would have in space? So yeah, that was a pretty cool mission. And actually, the people who worked on that Phonesat mission went on to create Planet, which is the company that I worked at last year. And so Planet is an Earth observation satellite company. And so they have the largest fleet of cube satellites in space. I think over 100 cube satellites currently orbiting Earth, taking pictures of the Earth. And so you can see this is a nice picture that they've taken. And I don't believe this is actually the Cubesat that took this. It might have been their bigger satellite, but similarly, their Cubesat takes pictures like this. And this is of San Francisco. And it's quite pretty. They can take many different pictures of like farmland to see how the farmland is changing, and how they can also take pictures of forests, of seeing how the effects of deforestation. They can do flood mitigation and management. They can see the effects of flooding, and also kind of try to help people predict when floods might occur. And there's just a lot of different ways that taking pictures of the Earth every day can help you see how it changes. And so how they do this is through a technique called the line scan. So it's a bit blurry, but basically it orbits Earth, and in a line, it takes pictures on each kind of interval. And then it kind of builds a picture of the Earth. And so they do this, they orbit often because they're in low Earth orbit, they're closer to the Earth, so they can orbit much quicker. And so they take a new picture of the Earth every day, and then they can compare it. So yeah, just a little side about my experience at Planet. I was an engineer, a manufacturing and test engineering at Planet, and I had a lot of fun. I had to wear kind of like this kind of get up every day with gloves and a mask, obviously because of COVID, and then a hairnet, because when you work with cube satellites or any kind of space technology, you can't have your hands kind of touching it. So these components, for example, have specific coatings on them. So if my hand oils get on it, it could wreck it, and the sensor may not be able to work as well. If my hair gets caught in the telescope, it could mess up the reading when it's in space. Even dust. So sometimes there's like super clean rooms, and like you have to wear like a full bunny suit with like, more than the coverage that I have here. And so yeah, it's very sensitive stuff that you have to work with, and it's a little bit scary because they're very delicate. So you might feel like, oh my gosh, I'm going to break it. But yeah, it's like really nice, all the people who work at Planet. So I never was worried about, doing anything because they trained me pretty well. But yeah, it was a lot of fun. And a really great thing that Planet also does is they launch art into space. So they have a bunch of these Dove satellites, this is what the Cube satellite looks like. And this is actually the solar panels that are kind of flown out like wings, which is an interesting, because it's called a dove, which is like a bird. And on the other side, you can't see it, but there's like solar panels. This is the telescope. This is the cover that comes out, and this is their antenna. But yeah, they put on this side panel, which is white and bare, usually they put art. And so I made some art, and they put it on the Q satellite, and one of these went up into space. And now my art is in space, and they have many, many different artists and people and students and, bunch of people who kind of make art and send it to space. So I would definitely recommend keeping your eye out, because they do have sometimes where they ask for people in the world just to like submit art. So keep an eye out for that if you want your art to fly in space as well. But yeah, so that was Planet, and it's a great example of a company or a commercial company working with cube satellites to actually do something in space every day. Another example of cube satellites, and this is for an exploratory mission as well as a technological demonstration. In 2018, NASA JPL launched the Mars Insight Lander with the purpose of learning more about Mars. So taking like readings of the environment as well as the vibrations of the Earth, so seismic readings, not the Earth, of Mars. And it launched with 2 CubeSats called Mars Cube 1 or Marco A and B. So they were Marco A and Marco B. These are the first 2 CubeSats of their kind to fly to deep space. And so remember how I told you that most CubeSats are in low Earth orbit. Sometimes they go beyond Earth and they can orbit the moon as well as Mars. And so Marco CubeSats are like that. And so when the Mars Insight Lander landed on Mars, it sent communications to Marco, as well as another spacecraft that's been orbiting Mars since 2010 called the Mars Reconnaissance Orbiter. And due to limitations on the Mars Reconnaissance Orbiter, InSight, when it sent the communication, there was a big communication delay, about an hour to confirm that InSight had landed. So it said to Mars Reconnaissance Orbiter, it was like, hey, I've landed. And it took an hour for it to receive that communication just due to like technological limitations. But with the Marcos, the 2 CubeSats that had come in 2018 with the InSight lander, when InSight said to Marco, hey, I've landed, it took very quickly for that to confirm that InSight had landed and it was safe. And this is what's called like near real time. So it's not real time, obviously, because for us humans on Earth, it takes like 20 minutes for communications from Mars to come to Earth. So it was like near real time, which is like right away Marco received it, but us, it took a little bit of time. So it's not because there was something wrong with Mars Reconnaissance Orbiter. It's just like I had mentioned, CubeSats are able to carry more up-to-date technology. So they were better equipped to send and receive communications since they launched in 2018 versus when Mars Reconnaissance launched in like 2010. So yeah, Marco was a technological demonstration and it was used to support a scientific mission. And with Mars exploration and things like that, time is of the essence. And with these types of missions, Marco is able to prove that there's capability of better communications relay between the lander and the orbiter and the Earth. And this will help to enable future space exploration missions and help us to go further beyond. So that was really one of my favorite missions. And also just another example of, CubeSat projects, there's student projects. So like I've been mentioning, I've worked on Cube satellites. I've done this through the Canadian Cubesat project. So that's me with the Nudos mission, McMaster Nudos mission. This is a rendering of what the CubeSat looks like. And this is me with my team. So in 2019, the Canadian Space Agency launched a project called the Canadian Cubesat Project to help support students across Canada to design, build, and test, as well as launch their own CubeSats. And so this was a university project that I worked on. And the goal, I think I mentioned earlier, was that it was to collect data, collect radiation data in low Earth orbit. And it uses this kind of payload right here. So there's all this like electrical boards that I mentioned, and then this is where the payload is. So it takes up quite a bit of space, but it does a lot of cool science. And so this is set to launch in 2022, like next year. And it's really a great way for students as well younger than me to even get trained on becoming scientists and engineers working on cube satellites and just scientific space missions in the future. In the same respect, AlbertaSat, as I showed you that video of that CubeSat deploying, was the first Canadian university to launch a CUBE satellite in, I believe, 2017. And since then, a handful more have. And so with the Canadian CubeSat project, 15 more universities will launch CubeSats across Canada. And just some good benefits of projects like this, at AlbertaSat, many students have gone on to work in the space industry as well as in many different cube satellite projects, and some have even started their own companies. So they now make their own cube satellites and get funding from different areas to do that. So there's a lot of great outcomes of working on a cube satellite, and there's so much that you wouldn't learn in a classroom. if you work on projects like this. And there's a lot of ways to get involved. Even if you're not building a cube satellite, you know, you can build the payload. So, hey, this is a great idea of something that could be used in space, but just needs a cube satellite. So designing a payload is a great way to also kind of get involved in space industry and just like testing stuff. There's a lot of ways to test payloads. You can test them on a cube satellite. You can also test them in a suborbital flight, like a reduced gravity flight. Those are called zero-G flights. So you get to float in space, as well as on high altitude balloons. Yeah, so there's a lot of great benefits of students getting involved in space, and it's very welcoming in the industry. So yeah, pretty much that's like my spiel. Pretty much is CubeSats make space accessible because there's so many different ways and different people who are involved. There's so many different projects that can be worked on for space, and because they're inexpensive and they have shorter time frames and are a little bit easier to design, a lot of people can have access to making them and iterate on them and improve on them. So you'll see like students and companies and government agencies all developing and launching cube satellites. So it's a really a great mechanism for accessing space. So if you're ever interested in getting involved, there's quite a few ways, as I mentioned. If you're interested in designing a payload or designing your own cube satellite, you can start a club at your school. You can start a project. There's also the CanSat challenge through the Canadian Satellite Design Challenge for high school students who are actually recruiting right now for next year's CanSat competition. So if you're in a high school and there's a cube satellite team, or you want to create a cube satellite team, this is a great funnel to get involved with that. SEDS Canada is another really great organization who supports students. There's a lot of different ways you can get involved. Like I mentioned with the payload stuff, they actually facilitate a lot of projects to go on suborbital zero-G flights to send up payloads on stratospheric balloons. And they really want to work more with elementary school students as well as high school students. So it's always worth a shot to kind of get in touch with SEDS Canada. And yeah. Also just reach out to a cube satellite team. So if you have heard about my 2 cube satellite teams, or if you look at the Canadian Space Agency's website for the other cube satellite teams across Canada, it's always worth a shot to email them. I've had emails from students in high school as well as elementary school who have asked questions or wanted to get involved in some way. And I think it's very important to kind of work together and kind of show the younger generations how to get involved, because hopefully all of you here will be involved in the industry as well in the future, and might as well start now if you're interested. So definitely reach out. You can reach out to myself as well. And that's pretty much the end of my talk. So as I said, you can reach out to me. My email is on the screen if you'd like. You can also follow me on Instagram or Twitter and also reach out to me there. So thank you very much.
Okay, thank you, Hira. That was amazing. I think I knew of many things, but there was still something new that I was learning in this process. So thank you again. And we have been having quite some questions come up on Slido. So I think Prachi will share her screen and you can see it, and also start after you have your sip of water. No rush.
Awesome. Yeah, no problem. So how do you want me to kind of go about this?
I mean, we usually go from the top down.
Okay, so, sounds good.
Yeah.
Okay, yeah. So is there some advantage against space junk for CubeSat specifically in that orbit? So let me think about this. So if you're asking the advantage of space junk, so yes, there's kind of 2. One is cube satellites generally, because they're smaller, in low Earth orbit, they'll deorbit quicker. So big satellites, the reason there's a lot of space junk is because they kind of stay up there for a long time. They're in different higher orbits. But cube satellites, they deorbit a lot quicker. So they can burn up in the atmosphere or fall into the ocean. And yeah, they come down much quicker than the big satellites. Another benefit to cube satellites is relating to space junk is quite a few actually are trying to develop different technological demonstrations of deorbiting mechanisms. So for example, York University last year launched a CUBE satellite called Descent Mission. And so that tested a technology to kind of anchor satellites and pull them into the Earth's atmosphere to burn up and, become, back on Earth to be collected. So yeah, there's kind of two, like CUBE satellites are better at not contributing to space junk. They do still to some extent, but they are better at not contributing, but they can also be used to help, test technologies to take down satellites that can be used later on. Yeah, I hope that answered the question. A lot of pros. Do you think CubeSats replace other kinds of satellites? So then we can, yeah. So it seems like there are a lot of pros to CubeSats. Do you think that CubeSats replace other kinds of satellites? If so, then when can we expect this to happen? So yeah, so I think there are a lot of ways that CUBE satellites can replace other kinds of satellites. And at the same time, they can't, I don't think yet, at least, replace all kinds of CUBE satellites. But I do think that they are pushing different organizations and industries to kind of get smaller and more compact. But pretty much it's about the technology. So as long as the technology keeps innovating and getting smaller and becoming more compact, then we can expect that smaller and smaller CUBE satellites like structures can be used and developed to do the same functionality. So for example, Planet is a good one. They initially back earlier in like a couple decades ago, Earth observation in general, so just like taking pictures of the Earth, required really big telescopes on these huge satellites. And so there was a company called Rapid Eye that would take these big satellites and launch them and then take pictures. And then when Planet came around, they kind of proved that you could take good quality photos, but in a smaller package, in a CUBE satellite package. So yeah, there's hopefully in the coming years, we will see more and more technology kind of get smaller and move towards these kind of packages. Yeah. Yes, so can you be a part of a CUBE satellite if you were in grade 5? I definitely think so. And I mean, other people might disagree, but I definitely think at any age you can be a part of it. You may have different expertise. There's quite a few talented young people out here that I have definitely seen. So I think it's always worth a shot to ask questions, find out if there are ways that you could start your own club or work with an existing club at a high school or university. Even just contributing a small portion of that and just learning. I think it's really worthwhile for younger students to get involved. And I've actually seen, I once went to a conference where elementary school students came up to me and were like, yeah, we're launching our CUBE satellite next year. And I was like, oh my gosh, like I haven't even finished designing mine. So I think it's always worth it. So yeah, ask questions, find out, talk to people. And sometimes people will say, no, but just keep trying. I think there are ways for sure. Okay, are there any regulations to bear in mind if you are planning to launch a satellite into space? Absolutely. There's a lot of legal stuff and government stuff that you have to deal with. It is quite a hefty topic, so I won't get too much into it, but pretty much there's a lot that you need to be mindful of when you're going into space. You're taking up real estate. You have to make sure that when you're communicating that you're not messing up other people's communication, other satellites communication. You got to make sure that you're not going to bump into another CUBE satellite or another satellite in general and cause problems. You got to make sure that you're not going to hurt or hit the International Space Station when you're leaving that deployer. You got to make sure that you're open, you're on the ground when you're communicating on the ground, that other people can also listen in, and if you don't want them to, that you need to make sure that you encrypt your data. So there's so much that goes into the logistics of launching to space, and like a lot of people need to approve and like say okay for you to launch. So that's why there's all those design reviews that I talked about a little bit earlier. but yeah, there's just a lot of work that goes into it. Like it would be really fun if you could just build one and send it, but you got to make sure that you're complying with a lot of regulations and yeah. Okay, what if I build a satellite and it blows up in space? Would I go to jail? This is a very interesting question. I actually don't, yeah, so I don't think you would go to jail because, as I mentioned, there's a lot of regulations and there's a lot of people who are all kind of participating to make sure that something like a satellite blowing up doesn't happen. But it's a very unlikely chance that it would happen. And I don't think just one person would be liable for that. And likely you definitely would not go to jail. So there's quite a few people who would be involved. There's like my team, for example, at McMaster is like 80 people. So like there's a lot of eyes on this Q satellite to ensure that it doesn't have anything happen to it. And yeah, if it had any risk of blowing up in space, they would never launch it. So don't worry about that. Yeah, definitely don't worry about that part.
I think in general, it was if they do an investigation and then they find that someone as a nation or a company, etc., intentionally caused for any sort of damage, then they would certainly fine them. I don't know if going to jail would be that extreme, but it's not like it goes unnoticed. So there will be, there will be an investigation for sure.
Oh, definitely.
What's the next one?
So how do you ensure your satellite does not collide with some other satellite? Okay, yeah, so there's a lot that goes into this, and this is back to like that regulations type thing. So there's a lot of people who are monitoring as well satellites. So, but you yourself, your team, your organization is responsible for ensuring that wherever you launch, whichever orbit you choose, does not interfere with other satellites, and that if you could potentially collide, that you have propulsion. So I didn't talk about propulsion much, but there is ways that there's little, things that can push the satellite up or down or in a different way so that I could avoid a collision. So it's your responsibility. It's also, space is quite big. So like it does look like there's a lot of things really, really close together, but there's quite a lot of space. So the hope is that you're launching into an area where you are ensuring that you won't hit another satellite. And there's a lot of government bodies who are monitoring this and ensuring that you also will not, and will be telling you exactly where you have to launch to. So when you get deployed, the ISS, for example, is that person or group that is ensuring you launch into an orbit that will not interfere. And then, you basically track your satellite, and other people are also tracking your satellite because everyone can see all satellites at all time. And if there is a potential for collision, you'll be notified, and both whoever is colliding will have to either try to avoid, or if it is a collision, that it, doesn't cause a big issue based on measures put in place. But yes, it does happen. It can happen. What positions are there in a CubeSat team? Good question. So there's quite a few. We have things like upper level people who are, researchers, principal investigators. So those are kind of people who are kind of leading the project. So they're, if it's a university CubeSat team, it'll be kind of those people who are directing the science of the mission and also the way that it goes. And then below that, you have student management. So people who are like project managers or leads. And then you have kind of sub team leads. So if there's a mechanical system, there's someone who leads that, electrical system, someone who leads that. And then below them, a lot of different people who are specializing on different areas of the satellite team. And so that's kind of similar in a company as well, on a CubeSat. That also has like different levels of those, but there's so many types of people who are part of these teams with different specialties. I've seen physicists and scientists of different kinds, and different types of engineers. So not just electrical or mechanical engineers, but materials engineers, chemical engineers, different specialties. There's also room for business students and lawyers. As I mentioned, the regulations, you need people in law, you need business people who can manage finances, you need multimedia people to help with renders, and also art is a big part, as you saw. So like so many different types of people who can be involved in a mission like this and make it successful. Are there other kinds of satellites which companies prefer over CubeSat? If so, why? Yeah, so as mentioned, there's like conventional satellites, some of them called like, so we have cube satellites and nano satellites in one area. And then above that, you got like micro satellites, medium level satellites, large satellites. I don't know the full technical names, but there's the bigger versions of the satellites. And some companies do prefer that because, you know, cube satellites are great. They're awesome, but they do have limitations on their functionality, as I mentioned. So if you want a better, you know, resolution of a camera, you'll need a bigger frame to send that up. And so you'll need a bigger satellite. Same thing with communications. If you want better communications, sometimes you'll need a bigger antenna. And so that won't fit in a CubeSat. So you'll need a bigger satellite. So yeah, I think like generally they're good, but yeah, they have some limitations. Yeah, so can elementary students participate with CubeSat? Yeah, so again, definitely, I think you can. I think you should reach out and find ways. Did you plan to get involved in the satellite industry from the beginning of your undergraduate career? If not, what made you interested in satellites? Yeah, I definitely did not. I had actually no idea about satellites. I didn't even know that I could work on a satellite, let alone, you know, work in the industry. But when I first started an undergraduate career, I was like, still not sure even what kind of engineering I wanted to do. I was, you know, still thinking about maybe I'll do astrophysics, a little bit like maybe a minor, because like I didn't know how engineers could get involved with space. But I basically learned that as an electrical engineer or any kind of engineer that I could work in a space project. And yeah, it took me a couple of years to get there. It was like after the end of my second year, so halfway through my undergraduate degree, that I was like, oh, I can join this team because they do space things. And I just knew that I liked space. I just didn't know that I could work in space. So I will always say this 100 times, whatever background you are in, whatever, you know, field of study you choose, if you really want to work in space, there's ways. And I think just, you know, talking to people and talking about your interests and finding ways to combine that or, you know, work in that field. There's a lot of ways, you know, space is just another place. It's like we do everything on Earth, but we have to do that in space too. So you're going to need all kinds of people to do that. So yeah, and it's never too late. You know, I still don't really know. I'm in my master's degree. I still don't really know what I want to do when I graduate. So yeah, don't worry if you don't have it all figured out right away. So when was the first cube satellite? Oh yeah, so this was in 2003. So like I mentioned, in California, Stanford University and Cal Polytechnic, they developed the cube satellite model. And then in 2003, they launched the first cube satellite. I don't know too much about what it did, but I think it was just to show that you could make a small version of a satellite and launch it, and it could do a bunch of stuff. So why are cubesats in the forms of cubes and why not a sphere pyramid? This is a good question. I think the cube is just like a good form factor. Like you're not wasting a lot of space on the edges and you can fit a lot of things on a board. You can fit a lot of things inside of it. A sphere, for example, is a lot harder also physics wise, I think, to go into space. Same with the pyramid. So like cubes you can stack, you can like, they're very consistent shapes. A pyramid, I don't think putting two pyramids on top is that great. You know, you have different angles and stuff that goes on with that. So I think that's why they chose cube, because it's just like an easier, more modular design. If you want to have 3 cubes, then it's like just stacked and it's very uniform design. But yeah, that's a great question. I feel like I will definitely do more research on that. So what do you think is the minimum age to be in CubeSat? So I think any age. I mean, obviously there's a lower end to that. So like if you can understand kind of certain aspects of space and like what yeah, basically, if you're able to understand kind of what's going on with the cube satellite, I think at any age you can get involved. Like, again, I'm in my master's and I'm still learning all the time. So if you're interested and you're willing to learn, like, I think you can get involved at any age. But yeah, if it's something that you're like, oh, that's really cool, and like I'd love to see how I can get involved with that as I go along, like keep it in mind every year and just like see if there's different ways to get involved. And even if a cube satellite is not something that you're as interested in, there's smaller ways. So like you could work on, you know, a small electronics project that could go on a cube satellite, or you could work on, you know, a stratospheric balloon, and like later on in your career, you could send a cube satellite on that stratospheric balloon. So there's a lot of ways to get involved with space, but yeah, any age, I think for either of those. So where do you look for opportunities to submit art? So for Planet, definitely following them on like Twitter, as well as just checking on their website. They have this thing called the Artist in Residency program. So like that link, I think I could find it and probably send it. But if you just search like Planet Artist in Residency on Google, they have like a whole page about their program and how they do that. But yeah, like you can submit art through there. It's not as often, but definitely keep an eye out with Planet. And of course, if I ever hear about it, I will send it to into space to share with the group. Yeah.
We just launched the poll just because we're almost at 6. So before, you know, it gets too late, we thought we'd run that. But Hira, are you available to answer a few more questions? Okay.
Yeah, for sure.
So for anyone who needs to sign off right at 6, feel free to. Thank you for attending, but we'll be here for a few extra minutes and work through more questions.
Yeah. Great questions, everyone. Yeah, so I guess we'll go to the next question if people are able to multitask. So should I be an expert in orbital mechanics to launch a satellite?
Oh, wait. Oh, you know what? Okay. Go ahead. You were able to read the question.
Oh, yeah.
You can answer.
Yeah,
so, I think Prachi might have had internet issues. So
no problem.
I'll share my screen.
Yeah, so orbital mechanics, I am absolutely not an expert in orbital mechanics. And so for anyone who doesn't know what orbital mechanics is, it's just understanding how space, environment, gravity reacts with spacecraft or anything in space. I am definitely not an expert in orbital mechanics. So if I can work on a satellite team and launch a satellite, you definitely can. You just need someone else who understands orbital mechanics enough to help you and make sure that what you're planning to do works. But yeah, definitely don't need to be an expert. And yeah, that's the best part about student teams is that you're allowed to learn, you're allowed to make mistakes. And there's a lot of people who can help you who are a lot smarter. There's so many people who are much smarter than me who are working on these projects. All right, so can cube satellites do the job bigger satellites do, for example, the GPS satellite? Yeah, so like I mentioned, for example, Phonesat, the phone has GPS on it. So they were basically also checking that they were able to get some of those kinds of readings. I don't know to the full scale whether a GPS satellite can be replicated on a cube satellite, but I'm sure that there's people working on that technology and again trying to innovate to make it better and smaller to kind of do that. But yeah, GPS satellites usually want to be very big and last longer. Cube satellites kind of go down quick. So if you want to always know where you are on Google Maps, you probably want a satellite that stays up there for a while. So what if the satellite hits the ISS? Well, I guess very good concern.
Very curious.
Yeah. So again, like also like Bhairav, you mentioned, if someone does it intentionally, then there will be an investigation and people will make sure that those folks are who are kind of on that or did that are fined or take responsibility. But again, there's a lot of regulations, a lot of things. For example, my Cubesat team, we had to go through this whole like section of our design where we were initially wanting when the Cubesat launched for the solar panels to kind of fold out and then kind of deploy is what it's called. And they had so many concerns about if we deploy, will it hit the ISS, things like that. So yeah, there's a lot of ways to avoid that, and so they try to do that as much as possible. But yeah, sometimes it happens. Sometimes things hit the ISS. Like a paint chip once hit the ISS and it caused like a hole. It's wild. Can I launch a CubeSat from a plane's window? So that's a very interesting question. So not necessarily, because you want to get into a specific atmosphere level before you can launch the CubeSat. So from my diagram, a plane is usually within like 10, 12 kilometers above sea level, whereas we want to be at like 400 kilometers above sea level to launch a CubeSat. So unless you had like a rocket that also launched from a plane, which actually there's a company called Virgin Orbit that does that, where they launch rockets from planes. From a plane's window, it would be very difficult because it would just kind of fall to the ground. So do CubeSats have engines? So kind of, yeah, some CubeSats have this thing like called propulsion. So that's kind of like an engine. It kind of pushes them and makes them move around in different areas in the orbit. And that's like really good for if it's going to collide with something, or if they just want to like, if it's like dropping a little bit out of orbit, they want to like push it back up. So propulsion is something that some CubeSats have. My CubeSats that I've worked on with my student team don't have that, but I know that with Planet, some of them I think have some propulsion that helps push them back into the right orbit so that they don't deorbit, or can push them down so that they do deorbit. So
it looks like Vihan has his hand up and wants to ask an actual like audible question. So go ahead, Vihan.
Could we leave because it's already 6:02?
Yeah, you could. I had already mentioned that.
Oh, okay, bye.
Bye. Okay. So next one.
okay, so can I make a CubeSat collect a sample of space, maybe a sample of gas in the upper atmosphere? Is it legal? Was it ever done? I actually don't know the answer to this question, but I would theoretically imagine that you could collect a sample of something. I don't know how they would do that, but I could imagine in some way you could. But yeah, no, actually, I think you could definitely do that as long as you have the instrument on board your Cube satellite to do the analysis, because you can't come back to Earth with that sample like a rover mission could. But you could definitely, yeah, there's a lot of people who test things in upper atmosphere. So like, I don't know. Yeah, I definitely think gases for sure they do. Yeah, there's like, for example, CO2 emissions. I actually don't know if that's in the upper atmosphere, but there's a lot of people who detect CO2 emissions. They detect space weather, they detect radiation. So I'm sure there's ways to also detect gas in the upper atmosphere. It is legal as long as you have all the clearances and like, this is my mission, this is what I'm doing with the data, and this is what I want to learn. As long as you do that, then it's completely fine. So how do CubeSats come back to Earth? So they just fall. They, like I mentioned, they will deorbit. Some of them, when they're coming back into Earth's atmosphere, because of like the gravity and like just the atmosphere in general, they'll start to burn up. So like if you ever seen a space shuttle come back into Earth, you'll see like it's like burnt on the sides and like it's like really wild looking. That's because of re-entry. There's like it causes a lot of like heat, and so cube satellites, some of them are so small that they'll just burn up. So like all of the materials will just like evaporate because of that heat. And sometimes if there's anything left over, they'll fall onto Earth. So they tend to hope to deorbit into the ocean so that any particles like that don't hit a person or an object. But yeah, they basically, we can't really get them back in their full form. But yeah.
So I will just mention, maybe we can take 2 more questions. So for the long list of questions still there, if anyone wants to vote, which is the top 2, we'll take those. And that way, yeah, we can let Hira also take a bit of a pause.
It's great. It's a lot of fun.
Okay, there are 2 questions.
Okay. So where do we look for opportunities to participate in a CubeSat program for elementary or middle school students? So I don't know of current ones available for elementary or middle school students, but I don't think that should dissuade you. I think, designing a CubeSat is definitely something feasible for a elementary or middle school audience. And so I would encourage you to kind of do some of that design. There's a lot of resources online, like CubeSat 101 from NASA. They have like a whole list of like what to look for, what to do, how to plan a CubeSat mission, things like that. The Canadian Space Agency, I think, has a couple of resources as well. So I would encourage you, if you're like, I want to design a CubeSat, to like get a couple of friends together and start designing one, and maybe get a teacher involved, like your science teacher or something, and try to get them to help you out, and then design a cube satellite. And then maybe there's ways to get involved to actually build that cube satellite. So I'm sure there's a lot of opportunities to do that. And I would definitely encourage you to find ways. I would also say, like, again, reach out to current cube satellite teams, reach out to SETS Canada, reach out to even the Canadian Space Agency, and there's a lot of ways to get involved. So yeah.
I think the NASA Space Apps challenges might also be a moment where you can test a solution.
Definitely.
Yeah. Okay.
So I'm
Final
the last one.
Yes.
Okay. Sounds good. So I am very interested in satellites and the space industry in general. However, I don't know what major better suit my interest. Any advice? Absolutely. Like I mentioned, I think that there are a lot of ways to get involved that are not just engineering and science. But if that's kind of where you're interested, I would say, like, try out different courses, find out on the baseline what interests you. Like, are you interested in science? Do you like math? Do you like using your hands and programming, or do you like building things? Do you like, figuring out like finances? Do you like, looking at the regulations for space? Like, figure out kind of on that level what you are interested in, and don't worry about test grades too much. Like, do I have the best math grades? Do I have the best programming skills? Do I have this? Because I didn't either. Like, I'm not the best at math. Like, I'm not the best at science, but I love it still. Like, I think it's very interesting. I just, I'm just not that great at testing sometimes. But I try. And I think as long as you're trying and you're trying to learn, and then you can get involved in any kind of major. But I would say, like, find out what you like to do, what courses excite you, and then go from there. The space aspect will come. I think there's so many ways to get involved. And yeah, by all means, like, if you have more specifics about what you're interested in or looking for, like, you can contact me and we can talk about it as well. I've definitely had a very weird way of getting into the space industry. And yeah, like, I think there's lots of ways.
Mm-hmm. Okay, that's a perfect note for us to pause, but great questions, everyone. And thanks to everyone for sticking by behind a few moments past 6. So Hira, again, thank you very much. We appreciate your participating, giving us this perspective about CubeSats. And I know there's a lot of interest in now wanting to design their own CubeSat. So we'll see what comes next. So we'll officially wrap up. Thanks, everyone, and we hope to see you next week. Bye.